Okay, so what questions do we have out of the variation? Do we have any of those questions to look at? And I'll probably pick maybe 2 or 3 of these to put on your final, and they'll be optional. Because I'll probably put 3 or 4 questions on there, and you'll be able to skip them. So there'll be more than 30 questions. Your final's going to have 30 questions that you're going to have to do. I'll probably add in a couple of extra, and they might be variation, they might be something else. But there'll be questions you've seen before, we really haven't went over in a while, but there'll be ones that you can either skip or skip something else. So there'll be some options on your final. But on your final on Wednesday, you're going to have to do 30 questions. There'll be extra ones that you can skip, but you're going to have to do 30 questions total, just like the practice final and the take-home. They're very, very similar. Only difference is different numbers in a different order. That is it. Pretty much, if you can do the practice final, you can do the take-home final, you can do this final coming up on Wednesday. So did we have any questions over variation and applications?
Yeah, no. I need help in 1 through 10.
Okay. Is there a couple of you specifically like for me to look at?
Just whatever you want, you can pick.
Okay, I'll pick a couple of each type.
I won't be picky because I am tutoring tonight. So.
Okay. How about for variation? How about we look at? Let's see. How about we look at the first one because that varies as the square root of the length. How about 1? How about 4? How about let's do an inverse? How about 6? And let's look at a joint one. How about, I don't know that we've done 10, so let's look at 10. So that's a little bit of all 3 different types. So there's a couple of direct variation and direct to a power. There's an inverse, and there's also a joint variation. What about exponents and logarithms? Which ones of those would you like for me to help with? And I do have your exam grader, Tracy. Okay, question number 8. Yeah, I'll get that back to you here later on. But okay. What other ones out of exponents and logs?
I think the one I left my homework at home.
Okay.
Can I see that packet real quick?
Sure,
I'm sorry.
sure. Yep, no problem. Yep. We can do that.
I think probably either 9 and 10.
Okay.
Whatever ones you want to do out of those 2.
Okay, I'll do question 9. And what about systems? Do we have any questions over the systems? That's that last page.
I want to say 9 or 10 off of that one.
Okay.
I can't remember which one I had trouble with.
We'll do 9 and 10 both.
Okay. Sorry.
Oh, yep, no problem. No problem at all. Okay, are there any others out of the systems or logarithms to look at? Anything else? Okay, we will start with these. And again, I've got your practice final. I worked that out. I did all 40 questions with detailed, worked out components. I did that last week. I got it posted online, but I do have physical copies I made for you. We're going to spend some time today going over these questions. And then what we're going to do after that is we're going to look at the practice final. There's some questions I really want us to focus on to make sure we remember how to do them. And then we'll have time for any other questions on the practice final that you might have. And we can also do some on the take-home. If we ask about the take-home final, I'm not going to work them out completely, but I'll get them set up and get you in the right direction. So I can work at about half of those and get it about halfway done. So let's now go ahead and look at the variation. And again, I'll probably put a couple of these on your final as questions that you can either skip or work through and skip something else. So when I make it up, I'll probably put 33 or 34 questions on your final, and you'll be responsible for doing 30 of them. So let's look at this variation question. And what variation works is there's 3 different types. There's direct variation, which is multiplication. Okay. There's inverse variation, which is division. And there's joint, where we have several things going together. either inversely or directly together to come up with a different component. So when we look at these, what we do is we have to find our constant. And the constant might be the effects of gravity. 9.8 meters per second squared is gravity. Might be something else like pi. Okay, 3.14 goes on forever. Pi is another constant. But there's all kinds of different constants for everything. Another constant might be the type of metal. If you're working with some type of spring, okay, each metal has its own type of constant to tell you how elastic the metal is when you make a spring out of it. So we're going to look at question number 1. The period of the vibration P for a pendulum varies directly as the square root of the length. So we are looking at the period, and that period is going to equal K times the square root of the length of that pendulum. And you can use L and the P if you want. I just write them out in words. That way we don't get things mixed up at all. That way we know what we've got. You can use variables, but on these, I write them out in words. Now what we need to do is we need to find that K. And we know the period of vibration is 3 seconds when the length is 36. So the period is 3 seconds when the length is 36. So we fill it in. Okay, so we just fill in our pieces here. And square root of 36 is 6. So 3 equals 6K. We'll divide by our 6, and then we'll reduce it. And now we've got our K to be 1/2. So we have to find our constant. So we've got our constant. Now we rewrite our formula. So the period is going to equal 1/2 times the square root of the length. And we want to find the new period when that pendulum's length is 2.2. And it says round to 2 decimal places at the end. So now we're going to use our new formula. And we're going to adjust the length of that pendulum to 2.25 inches. So now we'll plug it in. And we should be able to calculate the period, how long it takes for that pendulum to swing back and forth, when the length of that pendulum is 2.25 seconds. And what happens is, the longer the pendulum, the longer it's going to take, right, for that to swing back and forth. So as we increase the pendulum length, we increase the time it takes for the pendulum to swing back and forth. So we've got 2.25. We're going to take the square root of that. Okay, and that comes out to be 1.5. And then we'll multiply that by 0.5. And now we get our period to come out to be 0.75 seconds. So that's going to be the period for that pendulum to swing. And we decrease the length of the pendulum, so that also directly decreases the time it takes for the pendulum to swing back and forth. So one influences the other. So that's direct variation, and that one was directly to a square root. Question 4 is another direct variation question. The distance it takes to stop a car varies directly as the square of the speed of the car. So what we're looking for is the distance it takes to stop the car. So that distance, that's what we got first, varies directly. That means we multiply by the speed of the car. So the distance is going to equal k times the speed of the car, and it's in this case squared. So we have to square the speed of the car. Now we need to find our k. And our k might be different for every car, because k might be what type of tires you have. That can make a big difference. How heavy the car is. All those go into the factor of the k. So k is specific to the car. And every car is going to be different, but we can use that to figure out what the k would be for each type of car. Because we know the faster you go, the longer it's going to take to stop. And not just by a little bit, by the squared. So the speed makes a big, big difference on how long it takes to stop that car. Okay, so we're going to find our k for this car. It takes 112 feet for a car traveling at 40. So the distance is going to be 112, and the speed is 40. So we're going to use this to now calculate our k. And 40 squared should be, what, 1,600. So that's going to be 1,600k equals 112. We'll divide by our 1,600. And we'll go ahead and keep, okay, it says round, so we can go ahead and use decimals, because it says in the directions at the very beginning, round your answer to 2 decimal places. So let's try to round this k out to at least 3. That way we get an accurate result. So it says 2, so let's go ahead and round it to 3 places. You can use 4 if you like, but at least 3. That way at the end we round to 2. So we've got now 112. We're going to divide that by 1,600. And we don't even have to round because k comes out to be 0.07. So we didn't have to round at all. Now we can rewrite our formula. And then we still have to square that speed. Now there is our new formula. So we've got our adjusted formula with the value of k. And again, k might change depending upon the car. K would go down dramatically if you have a sports car versus maybe a big truck. Because the truck's going to take a lot longer to stop than a car would, especially like a sports car. So that's going to change that. So now what we need to do is we need to figure out what distance is required for this car to stop if it travels at 45 miles an hour. So the speed now, we're going to use 45. So we're going to plug that in. And now we can calculate this out. And we're going to round to 2 places. So it looks like 141.75. And that in this case is going to be feet. And this would be something that if there was an accident, the police could look at it and figure out, okay, so approximately how fast was this person going? And you could look at the skid marks and you could see, okay, this is how fast we think they were approximately. Next, we're going to look at question 6. And question 6 is inverse. Now, inverse means we divide. Directly means we multiply. So we're going to be dividing here, and we're going to be doing the same process. We're going to be trying to figure out what our constant value is, And then we're going to be figuring out the new value that we need to find. So the time it takes to complete a certain job varies inversely to the number of people working on that job. So this is question 6. So the more people that work on it, right, faster it's done, less time it takes, which makes sense. If it takes 32 hours for 7 carpenters to frame a house, then how long will it take 57 carpenters to do the same job? So let's see what we've got. Time it takes. So what we're looking for is we're looking for the time. Time varies inversely by the number of people. So the time equals K over the number of people working on that job. So there's our formula. And now we just plug our numbers in. It takes 32 hours for 7 carpenters to frame the house. So time is going to be 32. How many people are working on this? We've got 7 carpenters. So now we plug our values in. So 32 equals K over 7. It doesn't say anything about rounding, so we're going to keep the fractions if we have any. We can easily solve for K, though, because all we have to do is cross multiply. So we simply cross multiply here. So 32 times 7. That gives us then a value of K to be 224. So there's our new formula. So the time it takes to complete a job is 224 divided by the number of people that work on that job. Right? Is everyone okay with how I'm building these? They're actually very simple. All you have to look for is keywords like direct or inverse or direct to a square, inversely to a square root, something like that. Plug in the initial conditions, the initial values, find that K, build your new formula, and then answer the question. So now we want to adjust it, and we've got 56 carpenters working on this job. So number of people now increases to 56. So now we'll just look at our time. So our time is now going to be 224 over 56. And 224 divided by 56. Those both have a 56 in them. And so that reduces down to 1/4 of an hour. Right? Because these are in terms of hours. Or you could do that now in quarter of an hour is 15 minutes. Oh, wait, I did that backwards. Sorry about that. I divided it incorrectly. It should be 4, not 1/4. Sorry about that. I just looked at it wrong mentally. So that should be now 4 hours. So it should take approximately 4 hours if you have 56 people working on it. And yeah, the 1/4 didn't make sense anyways when I reread it. But
That's a lot of people.
well, yeah, but if you're building something like, let's say, a distribution center.
Oh, right. Well, right.
Yeah, you
I'm
would
thinking
increase
like
it to
a
56.
house or something.
Yeah.
That's a lot of people.
Yeah, I don't think they were
going
talking
over
about
each
building a
other.
house. I think they were talking about like framing maybe a big building.
Okay, good. This could not be me.
No.
You guys got enough people. I'm going home.
Yeah, that would be a little bit excessive. But it's probably something huge, like a huge distribution center where they've got lots of people working.
Well, I know when I started at Walmart distribution, there was still people in there doing stuff. I mean, there was painters still
Right.
in there, electricians still in there. I mean, there had to have been at least 100 and some odd people in there.
Oh, yeah.
Still.
So wind resistance or atmospheric drag, it's going to slow down an object, which we know, wind resistance slows things down, and it varies jointly as the surface area and the velocity. So we're looking at joint variation, and it doesn't tell us how, so we assume they multiply. Unless it says inversely, we assume they're going to be joint together. So we're going to look at the wind resistance. So we'll just call this the wind resistance. We'll just call it wind. And that's going to be K times the surface area and the velocity. So that's going to be our surface area. So the bigger the car, the more wind resistance or drag that it experiences, and the faster you're going. Also, the more wind resistance that the car has. So we're looking at question 10, and we need to plug our values in. It says speed of the car is at 40, so the velocity is 40. Surface area is 36. And it experiences a drag or wind resistance of 230.4. Plugging our values in, we've got 230.4. That equals K, which again is our unknown. We're going to have to multiply that by 36 and also by the speed in this case, which is 40. So that's 1440. K equals that 230.4. And these say round to the nearest tenth. So it says in the directions, round to the nearest tenth, unless it's specified otherwise. So we're going to round one more place than what we need. So we'll do 2 places. That way we can round to 1. So divide by that 1440. So we're going to go ahead and divide by that 1440. So 230.4, divide that by 1440. And we don't even have to round. That comes out to be 0.16. So that's our value of K. Now we can rebuild our formula. So the wind resistance or the drag that is experienced is 0.16 times the area times the velocity. Now we'll just plug our values in that they say that we've got. We've got the car now has a surface area of 38 square feet. And it experiences a drag force. Let's see, make sure we've got all the pieces here. Car's traveling at 40, 36. We did that. 230.4 is the wind resistance. So how fast? Now, we want to find the speed in this case, right? Because we don't know the speed. So they give you different parts. We're going to have to rearrange it a bit. So it says, how fast must a car with 38 square feet, so the area is 38, so that's the new surface area, and it experiences a wind resistance of 255.36. So there's our pieces. Now, normally we would just plug them in and multiply or divide, but we are going to have to rewrite this one and solve it because we want to find that velocity, right? We need to find the velocity of that car. So we'll go ahead and plug our values in. So that is 255.36. That's our wind resistance. We've got 0.16. We're going to multiply that by a surface area of 38. The velocity is still unknown. So we don't know that. So we'll go ahead and multiply those out. So 0.16 times that 38. That is 6.08 times that velocity. And now we'll just divide. and we'll find the speed or that velocity of the car. And so what's that velocity of that car come out to now be? Well, when we divide, we got 255.36. We're going to divide that by 6.08, and that comes out to be an even 42. So that car should now be traveling at 42 miles per hour. So there's several things go into the factor of how much wind resistance a vehicle experiences, and that's going to depend upon the area of the car. Some cars are built to be bigger surface areas than others, and also how fast the car is going. And K would be a constant, and it might be different for different cars. Every car might have a different constant, or maybe the temperature outside or something else can change the K. But you could calculate that K based upon the current conditions, and then adjust it to figure out what you need. So that now should take care, hopefully, of the variation questions. They're actually pretty easy, I think, once you start working through them. They're not difficult compared to some of the others. They are substantially easier than the mixture and the investment questions. I mean, you don't have to make tables. You don't really have to do much of anything. Just write out the formula, fill in the pieces, and solve. So now we do have some questions over logarithms and exponentials. The questions primarily relate to the logarithms and how those work. For question 8 and question 9, we're going to look at how fast bacteria reproduce and change, and how fast they either increase or decrease. If they decrease if you give an antibiotic, and if not, then they would increase. But we're gonna work with 9 in a moment. But let's look at question 8, and we need to use our logarithm formulas. So we need to convert a logarithm to an exponential, or vice versa. And I always like to write up our formula: y equals log base a of x. And that is going to now transform into x equals a y. So we're going to have to either go one way or the other. You can transform the exponential to a logarithm, or the logarithm to an exponential. So for question 8, we have the log base a half of x plus 6 equals a negative 7. So what do we need to do? Well, we need to look at our logarithm. We need to identify the pieces. We need to figure out what goes where, convert it into an exponential, and it should pretty much solve itself. So let's now go ahead and label our pieces. So the A is the base, and that's going to be a half, so there's that. This entire part right here, that is your x. And the negative 7, well, that should be your y. So let's convert this and see what we've got now. So x is going to be x plus 6, so there's that part, equals a, which is a half. And what are we going to have to do to that? We're going to have to take it to the negative 7th power. So is everyone okay with how we converted it? Right, so there's our formula. Y equals log base a of x. Make sure everything is wrote out correctly, and it is. Okay. So there's our formula there. We got everything labeled right. Now we've got to this point. Now we need to go ahead and work this out. And we can either use a fraction or we can use a decimal. I'm just going to use, I think, a fraction. So let's work with that 1/2. Okay, 1/2 to the negative 7th power. Well, whenever we have a negative exponent, remember, what does that mean? That means we flip it over. So 1/2 to the negative 7th power would be the same thing as 2 to the 7th power, wouldn't it? Right, remember, you can always flip things over when they have a negative exponent. And 2 to the 7th power, a 2yx or caret 7, would be 128. So now we've got x plus 6 equals 128. Move that 6 over, and that now gives you x equals 122. Now, you could have also just done this in your calculator, right? So you could have said, well, 1/2 is 0.5. Okay, so you could have put 0.5 in there. Now, you'd use the caret key. I use the yx key. But you use that caret key. And then you could do 7, and then hit your negative, and hit equals. And that would give you the same 128. You could do it with a calculator, or you can just rearrange it and do it by hand. Either way, then you set that equal to your x plus 6, move that 6 over, so x is now 122. Question 9. We're working with bacteria. And let's say these bacteria are dying off because you're given an antibiotic. So you're given an antibiotic, and the bacteria are slowly dying. And so here's our formula. It's an exponential. Exponential just means it moves extremely fast. And so in this case, it would be an exponential decay, so it would slide down like that. It's going to be a real dramatic slide down. Not just a straight line, it's going to dramatically drop off. So that's an exponential. And so here's our formula. Now we have to find our initial value, initial K again. So it says a bacteria has an initial population of 10,000. Its population declines to 6,000 in 6 hours. What will it be at the end of 8 hours? So here's our formula. P equals I E to the KT power. P is the ending number of bacteria that I have. I is the initial or the starting number of bacteria I have. And T is going to be the time. So let's now fill in our pieces, and we're going to have to calculate our K. So how many bacteria do we end up with? We end up with 6,000. So we end up, after applying the antibiotic, we end up with 6,000. We had 10,000 to start with, so a lot of bacteria. So we had some kind of serious infection. We gave that person an antibiotic. It decreased it. And it decreased it to 6,000, and it did that in 6 hours. So there's our pieces. So now we've got our 6,000. That's going to equal, we started with 10,000. We have E, and we have KT. T is 6, so that's going to be 6T. We talked about this a little bit last time. What undoes an exponential? An ln or a natural log. So they're opposites. Natural logs are used a lot in statistics. If you take a statistics class, a lot of the formulas are going to involve, especially like Poisson and things like that, are going to involve a natural log. So we get it by itself, so we divide by our 10,000. And remember, whenever we divide like this, we can reduce this down very easily. So we'll go ahead and cross those triple zeros out. And we know that 6 over 10, well, that's going to reduce down to 3/5. Is everyone all right with that? So we got the e by itself. Now, how do we get rid of that e? Well, the opposite of the e is the natural log, the ln. We're going to take the natural log of both sides. And we just use our calculator. So this is the ln. And every calculator is a little bit different. Mine has the ln key or the exponential key. Now yours may have the e key, but yours will probably have an ln. You'll see a little e to the x above it. And that would be the second key. We don't want e to the x. We want to go ahead and take the natural log. And so we use our calculator and we use the decimal. So 3 divided by 5, okay, that's 0.6. So we've got that. Now we take the natural log. And that comes out to be, and we'll take this out to 4 places. And that's going to be a minus 0.510 if we round 8. Now the natural log and the e, those cancel out. And that leaves you with then 6t. And now we'll finish it. All right, we're going to finish this by just dividing by the 6. Or 6k there, sorry about that. It should be a k, not a t. That should be the k. So we're going to find our k. So we'll divide by the 6 there, because that's our time. And that's going to now give us our k. And we'll round that out, again, to 4 places. So now we know that our k is going to be a minus 0.8. So minus 0.08 if we round 5, 1. So that's our value of k. And k would be the strength of the antibiotic, or what type of antibiotic it is, or how effective it is. That's going to be your k, how fast it goes down. Now, why is it negative? It's negative because we're decreasing the bacteria. If we were increasing the number of bacteria, it would be positive. And k might be something like what type of surface it's on, or what type of nutrients are there for the bacteria. And so that would be your k in that case. But in ours, we're decreasing it over time. Now, we want to figure out how many bacteria would be left in 8 hours. So now we're going to readjust it. So here's our formula. P equals, now the initial condition stays the same. We still have 10,000 bacteria at the beginning. And then we have E to the minus 0.0851 T. And now we want our time to be 8 hours. So how many bacteria would we have left in 8 hours? Well, we plug it in. So we'll just plug in that 8 there. And then we've still got our 10,000. And we're going to go ahead and multiply these out with our calculator. So 0.0851. We'll multiply that by 8, and that's going to still be negative. And that's going to be a minus 0.6808. Is everyone okay with that so far? Right, we just did that piece. Now, remember, what undoes an exponential? Natural log. You don't have an E key in your calculator, but on most calculators, if you look at them, above your ln key, you're going to see an e to the x in a different color. So you're going to have to push second, or in my case, inverse ln. So yours will probably have to do the second ln first. Mine's the opposite, so I have to do this first. And then I hit inverse, or second ln. And that gives you that. And then we're going to multiply that by our 10,000. And that gives us about 5,062 bacteria left. Okay, so when you're when you calculate it all the way out, should come out to be about 5,062, and the closest one there is answer D, and we're off by 1 bacteria, which is well within the margins of error there. We might have rounded a little bit differently than they did at one point, but it's close enough. So we would be left with about 5,000 bacteria in 8 hours. And so it would just decrease over time after that. Okay. Now we'll look at the systems, which 9 and 10 are those, and then we'll look at our practice finding.
Which one again? I'm sorry.
We're going to go on now to the systems, the last page, and we're going to look at 9 and 10. So we'll start with 9.
Could we also do 6 and 7?
Sure, yep, we can add 6 and 7 on there as well. So we'll then start with question 6. All right, so we'll start with question 6. Now you can use substitution. The easier way, though, in most cases is going to be elimination. I had to show you substitution last time, but we did a lot more with elimination. Now, when we eliminate, we want to eliminate for one of the variables. And what we want is we want either the x's to be the same or the y's to be the same and opposites in signs so they cancel out. Now, if we look at the 5 and the 10, well, that's easy enough to see because 5 times 2 is what? 10. Okay, one's already positive, one's negative. So let's take our first row here, our first equation, and let's multiply that by 10. And that 10 has to be, or that 2 has to be distributed all the way through. So 2 times 5 is 10x. 2 times a negative 8, well, that's a negative 16. 2 times 1, that's a 2. And the second one, well, we can just copy it, and look what happens when we add these down here. Not just the x goes away, but also the what? The y, right? Both of them go away. And when we add down, then we get 0 on the left. And what does it equal on the right? 2 plus, unless I copied it wrong. Did I copy it wrong? Nope. 2 plus 1 makes it 3. Now, does 0 equal 3? Can that ever happen? No. So this is a contradiction.
Okay, good.
And that means you have no solution, right? Because the variables disappeared, and you were left with something that was not true. Is everyone okay with that? Now, 7, I believe, is different because 7, you're going to have an infinitely many number of solutions. So for question 7, you've got x minus 2y equals 8, and the other one is a minus 3x plus 6y equals a minus 24. And we want to try to eliminate one of the variables. And when I look at these, I can either do the x or the y. They're going to work the same way, either one. When I look at this, I've got an x, and the one below it is a minus 3x. So that means I need to multiply the first equation by what? Can someone tell me? Okay, this has a minus 3, so this one needs a 3, right? That'll make it 3x. So let's rewrite this and distribute that 3 through. So that gives you 3x minus 6y. 3 times 8 That's a 24. Is everyone okay with this now? Right. Now, unlike the last one, which was false, and it came out to be a contradiction, this one, what happens here? 0 equals 0, and does 0 equal 0? Yeah, that's true. So that's like an identity. And how do we get our answer? Well, to get our answer, what we need to do is it says we want an arbitrary x. So what we do is we solve it for y. So we know it's an identity. And if it's an identity, what we do is we take it and we solve it for y. So solve one of the equations for y. So just take that first one, just move that x over. You can do any of them. They're all the same. So it doesn't matter which equation you pick. Just take one of them, solve it for y. So minus 2y equals now a minus x plus 8. We'll divide by our negative 2. And y equals now minus 1/2 x minus 4. Oh, wait, positive 1/2 there. Because negative and negative makes it positive. Now, how do we write our answer? Well, we write our answer kind of as an ordered pair. It's a little bit different, though. X is arbitrary, so x goes first. And when we solved it for y, what did we get? Y equals 1/2 x minus 4. So that's our y. So that's 1/2 x minus 4 there. And that would be your answer. So that's how you would correctly write the answer. And all it's saying is any number that is on that line is a solution. And that's what it means, because these lines were actually the same. They looked different from the beginning, but they actually came out to be the same. Those are the only two that are like that. 9 and 10, you're going to solve them, and you're going to get an actual answer. The ones on your exam are going to give you an actual answer. So 9 and 10 here. Minus 6x minus 6y equals 18. And 2x plus 4y equals 12. Now, when we look at these, we always look at our numbers and we try to figure out which one's going to be the easiest to deal with. And we don't want to have to multiply both equations. We want to only have to do one if possible. So when I look at the 6 and the 2, can I multiply that 2? We're looking at the x's here, 6 and 2. Can I multiply that 2 by something to make it a 6? Yeah. What would you take 2 and multiply it by to make it a 6? 3. Okay. Do we need a negative 3? No, because this one's already what? Negative. So we're just going to take the second equation and we're going to multiply it by a 3. Now you could have done 6 and 4, but that would be a 12. Least common denominator of 6 and 4 would be a 12, and you'd have to multiply the top one by 2 and the bottom one then by 3 to make the 12. That's a lot more work. So we want to always look at it and do it in as few moves as possible. 6 and 2, that's easy because 2 times 3 makes it 6. So we're going to use a 3 for the second half, second equation. Now we're going to keep the first equation exactly as it is. But the second equation, we're going to multiply everything by a 3. So 2 times 3 is 6. Bring the x down with it. 3 times 4. 3 times 4 makes it a 12y. And 3 times 12, that's going to now make it a 36, isn't it? Is everyone okay with that so far? Now, what variable have we eliminated? Well, when we add down, the x's cancel, don't they? And that's what we want. Our goal is to get this down to one variable. So the x's are gone. And we have a minus 6 plus 12. Those both have y, so that leaves you now with the 6y. And we're going to go ahead and add down here as well. And we've got 18 and a 36. Add down. That's a 54. We'll divide by our 6. And now we've got one part. So we now have our y. So y is going to be 54 divided by that 6. And that comes out to be a 9. Okay, is everyone all right with that so far? So we got one piece. How do we get the other piece? Once you've got one piece, you take what you got and you plug it back in. Now, it doesn't matter where you plug it into. Plug it into one of the equations. And so I'm going to go ahead and plug it into this one. So we'll just plug into the top one. And we're going to use y equals 9 here. And we've got a minus 6x. Minus 6y equals 18. So we're going to be plugging in that 9 for the y. So minus 6x minus 6 times 9 equals that 18. So minus 6x minus, what is that, 54 equals 18. We're going to add that 54 to each side. And now we've got a minus 6x now equals 18 plus 54. That's a 72. Divide by our negative 6. And it looks like x now equals we divide out 72 divided by negative 6. Well, it looks like x equals now a negative 12, doesn't it? Right? So we've got both of them. Do you see what we did? We just took one value, plugged it back in the one of the originals. Doesn't matter which one. And we found the missing variable. Now we have them. We write them out as an ordered pair. And this is x and this is y. So our x was a negative 12. And y was now our 9. So pretty simple on these. Now they do get more complicated as you increase the number of variables. On your exam though, and your homework and everything else, I just limited it to 2 variables. If you get much past 3 variables, you're going to almost have to use a computer to solve because they get so tedious and time consuming. If you go much past 3 variables, you've got to use a computer. Question 10. We've got 7x plus 9y equals a negative 7. And we've got a minus 4x plus 3y equals 4. And we'll take a break after this question. Where would we begin? What would you want to multiply by? And which equation? If I gave you this and I said solve it, where would you begin? Okay, you would eliminate the y, right? Why would you want to eliminate the y and not the x? Well, 7 and 4, they don't have anything in common, really, do they? So I would have to multiply this one by 4, this one by 7. And that would mean 2 multiplication steps. If I look at the y's, though, we have a 9 and we have a 3. So I can multiply the second equation by a what? 3. Now, a 3 is not going to exactly work because this one's positive and this one is also positive. So we actually need to make this a what? Negative 3, don't we? So that way we have a positive 9y and we have a negative 9y. And that way they'll cancel out. So let's go ahead and do that. The top equation stays the same. 7x plus 9y equals a negative 7. The second equation, we multiply it through. Watch out for your signs. Minus 3 times minus 4. Well, that makes it a positive 12x. Minus 3 times positive 3. That makes it a minus 9y, and that's going to cancel. And then we have minus 3 times 4. Minus 3 times 4 makes it a minus 12. We're going to go ahead and add these down. The y's in this case are going to cancel out. And 7 and 12 makes it 19x. And minus 7 and minus 12, that makes it a minus 19. Divide by your 19. And now we've got x equaling a negative 1, don't we? Now, we need to get both x and the y, so we take our negative 1 and we plug it back in. So we're going to plug it back in. So we're going to plug in x equals negative 1 here. So that's 7 times a negative 1 plus 9y equals a negative 7. So negative 7 plus 9y equals negative 7. We're going to add our 7. And now we've got 9y equals 0. So y equals now 0. So what's our answer going to be? We've got x and y here. X was a negative 1. Y solved out to be 0. And that's it. Let's go ahead and take a short break. We'll come back, and then we'll look at our practice final.